Hello, good morning, and welcome back to our HVAC Controls Fundamental series. Today's session, which we're super excited to present, is on BACnet MSTP versus BACnet IP and building level networks. It's a great session and especially relevant as building automation systems, converge more and more with IT standards. But a few housekeeping items before we begin. One, please ask questions in the questions tab. Secondly, these are 30-minute sessions, and then Grant and I will stay on for maybe an additional 15, 20 minutes to really try to answer as many questions as we can. Third, there is another session today in 3 hours at 11 a.m. Pacific or 2 p.m. Eastern time. So if you have to leave early or want to tell a friend about it, please, or just want to join Grant and I again, feel free to join us at our second session today. Lastly, if you haven't already, please follow us on LinkedIn and Instagram, and there you'll find all the latest news, new product announcements, on the latest Distech technology. All right, and I'm Stephanie Shahowski. I am the Regional Sales Manager for Distech for Southern California. And with me, this handsome gentleman right here across the coast, Grant Butler, Regional Sales Manager, New York City.
Thanks, Stephanie. Yeah, so two more housekeeping things just to point out. We do have the handout directly attached. You can locate that on the handouts tab if you want to take a look at the PDF version of this presentation. And then the other thing I wanted to talk about is the PDH credits for those that were going for that and have done a good job, attended the first two sessions so far. This final session is the piece that you need to get the sign off towards those 1.5 credits that were registered towards New York City. So if you've attended all three, then we'll be able to hand that out. But definitely, you're going to want to stick around for the other sessions because we got a lot of great content coming up after this one as well. With that, I'm going to go ahead and move into the presentation. So here's a look at our agenda for today. We're going to kick it off by talking a little bit about building networks, move into MSTP versus IP, and then explore network architectures and wiring strategies. And then finally, we'll hit on the customer network question of whether or not to use the customer network versus a separate network. It's definitely a hot topic, good thing to have a discussion around. So I want to get us back in line with where we started and now where we're coming to. So we originally kicked off these presentations covering our input and output devices. Those are all your sensors, your valves, your actuators. All those devices we said are wired back to unit level controllers. So every single piece of equipment has its own unit level controller and its associated sensors are wired back to that. So something like a VAV box, its damper actuator, its space temperature sensor, its airflow, all that are directly housed at that individual unit, wired to that unit. That allows for it to maintain all the safeties as needed for that piece of equipment and also have operation in case it loses communication with the rest of the BAS. Now we're moving into the building level. So we're now looking to network together all these unit level controllers. So all these pieces of equipment, we want them to work together to really start to optimize that system. So here's some of the things that you get out of having a building or even an enterprise level system. So you're going to start to aggregate a lot more data together and be able to make informed decisions based on the data available rather than trying to make some assumptions towards things that can help reduce your energy usage. You're going to have the data available to make informed decisions. And What you get even more so at the enterprise level is an enterprise level really is just using a server, and that's allowing you to store and collect even more data over longer periods of time. So a server, associate that with your enterprise level and having more data stored for longer periods. The other thing that you're looking for is optimization. So we talked about not having your facilities team running from room to room adjusting thermostats. So you have optimization in terms of that level, but then you also have optimization with your energy usage. So you're able to start to team together these disparate pieces of equipment such that you could leverage strategies that will reduce energy. Some global functionality is really a nice thing that you get out of a control system as well. So rather than having 20 different outdoor air sensors associated with each individual piece of equipment, you could globally network that across the BAS system and make it so that that outdoor air temp, humidity are pushed across to other controllers, whether or not even though it's not directly wired to them. So that helps with your cost savings and setup for your system. And finally, the thing that's really important to start to notice is that BAS systems are no longer being used just for HVAC. It's really gotten spread out across a lot more systems. You're having lighting being integrated, you're having access control, security cameras, you're having different pieces of your plumbing setup being, that have your sewage pumps, stuff like that. All these things are starting to get integrated into a BAS system. It's really become the catch-all system for a lot of technology within your building. So here's some additional functionality that you can get out of a building automation system. There are, like I said, there's certain energy optimization strategies that you need to be able to network controllers together to implement. So something like fan pressure optimization relies on an air handling unit working in unison with your VAV boxes and then being able to communicate with one another and ultimately reduce the amount of fan usage that you have at your air handling unit. Some other things that you can look for and get out of a system, we talked about energy savings. It's also really good for commissioning and making sure that everything is operating the way it should be. It's a lot easier to check some values in a BAS system versus having to actually go to the physical piece of equipment to check it out, make sure that it's working as it should be. Then finally, this is prevalent in New York City, but I'm imagining it's going to spread a lot to other cities. Steph could probably attest. California's, they're definitely also very aware of energy usage in cities, and so local laws are going to start to require compliance reporting and other ways to proactively monitor. So having a BAS system really helps with that.
Yeah, and especially relevant now in California, where many customers are experiencing blackouts. A common thing we do here and across the United States is automated demand response. So being able to, tie into the grid and being able to, adjust your system accordingly, adjusting those set points to help, the grid avoid those blackouts for customers.
Yep, absolutely. So now we're going to move into a discussion of BACnet MSTP versus IP. I like to start off with this drawing just to give you an idea of what a traditional setup looks like for a control system. This is still definitely very relevant today, used in a lot of facilities. We're going to show you how networking can be done a little bit differently on the IP side of things. So starting with a MSTP or LAN or Modbus, RTU, all these strategies, what they typically do is they're going to use a building level controller. So that's this guy up at the top. and they're going to daisy chain all the unit level controllers back to this building level controller. So this building level controller is going to ensure that everybody's working together, playing nicely, combined together, control strategies, scheduling, and so on and so forth. Like we have an MSTP link going back to this controller. We're also showing LAN controllers all being networked back to this, even Modbus. And then ultimately at the top, it communicates out IP to your local area network and your facility staff front end computer. But what's happening here is the speed of communication and the security and everything is kind of down to what's happening at these unit level controllers. So some of those IT security practices that we're going to talk about, it's a little bit harder to implement over these serial communications that we have here. So now taking a look at an IP architecture that you could have, this is kind of showing off what we like to call a flat IP architecture. This is definitely a strong preference for what I would like to see in new facilities. Personally, I think this is the right approach to have not only your building level controller operating with BACnet IP, but all the other controllers within your site as well, being able to communicate that BACnet IP. So you have a large plant, large air handler controller, rooftop unit controller, even smaller terminal controllers like VAV box controllers, water source heat pump, fan coils. They're all utilizing that same IP communication. So it's very consistent the whole way through.
Yep. Not only IP communication, or as you notice with the Wi-Fi adapter, BACnet over Wi-Fi, but I like to go a step further and refer to this architecture as it's a mouthful, but it's a flat, distributed, or decentralized BACnet over IP architecture. So what we mean by decentralized is in the previous architecture slide Grant showed, where we call that our traditional architecture. A lot of those higher level functionality is based in that JACE or building controller. However, when we take a look at this flat decentralized architecture, one of the ways us and other manufacturers are able to do that is just put a lot more horsepower processing speed into each and every BACnet IP controller. So we didn't just slap an Ethernet switch on our controller and call it IP, but really it's dramatically different and be able to have functionality like native REST API capabilities like we talked about in the last time, but the controllers themselves are a lot more powerful, which is one of the main reasons we're able to do this flat architecture.
Yeah, yep, that's a great point. So this slide, we're really starting to get into the details. I think this is a good thing to be able to refer back to the slide 100%. We have a lot. I know there's a lot of content on here. We're going to focus in this top left corner on the pros towards BACnet IP, and a lot of those pros end up being cons towards MSTP is what you'll find. So like we said, speed of communication is becoming ever more essential with a BAS system. You're starting to have a lot more data needing to be moved around within that system. It's no longer just HVAC, so you want to have higher speeds of communication. And what you'll see is that the difference is pretty substantial. You have 100 million bits per second versus about 100,000 bits per second in terms of speed of communication between IP versus MSTP. The next very big difference comes down to IT security practices. So as we said, BAS system is no longer set up like they were originally, and the intentions originally were in 1995 of it being kind of its own standalone system separated from IT. There's a lot more interaction with IT at this point, and IT technologies that you really want to be able to have a system that cleanly works with IT systems and is able to maintain the same level of security as what you see on the IT side of things. So there's a lot more security that's available over this IP communication as opposed to your serial communication, which really along that serial communication chain, there's next to no security along that chain. So it is very important to have that available. It's going to become more and more prevalent. The other cool thing is that this Cat5, Cat6 Ethernet cable, it's not just associated with the HVAC BMS side of things, right? This is associated with all of IT. It's the way you're plugging your computer into your router. A lot of new smart devices and systems are all leveraging this style of cabling. So if you build out the architecture with IP, you're allowing easier access points and ability for multiple systems to plug into your Ethernet switches, work together. If you're bringing in a lighting control system, you're bringing in security cameras, which are also very often going to use that same cabling type. You now have that network in place based on setting up these switches in your Ethernet backbone. So very robust physical layer. 4 of the conductors are just purely for redundancy. So it is easy to maintain. It's definitely easier to troubleshoot. Distech controls, we noticed a lot more phone calls in terms of troubleshooting issues, mainly around grounding is what we found with MSTP controllers versus all that goes away whenever you transition over to IP. You have a lot less issues in terms of just purely getting that communication working. And that kind of comes down to it's consistent with your wiring gauge, with your transceivers at the controllers. It's the exact same RJ45 clip going in. So, and you can now start to leverage things like patch cables, which, you know, you could go to Radio Shack, Best Buy, any of these places and pick up a 25-foot patch cable to go from one controller to the next, rather than having to put on these clips in the field. You can just get a prefabricated cable, which saves time and effort on the installation side. So you can see this little diagram over here is even kind of pointing out a lot faster of termination speeds whenever you're using that IP communication. Less gateway devices as you move into the IP protocol. So, and it's just a really good scalable infrastructure. So very helpful to install along this with BACnet IP. And I personally think that it's the way to go for any new buildings. You should be looking at IP. And the controls contractors, controls manufacturers that do it right, they can really bring together a lot of awesome features with their IP product line that are just not available with MSTP products. So Stephanie was pointing out RESTful API. You can't do that over MSTP communication. So starting to leverage all these different interesting technologies as we move forward. It starts with an IP controller, and I would say the ones that manufacturers that are really doing it right, you're going to see a lot of cool features available.
Yeah, the analogy I like to give is, again, the MSTP and existing building automation technologies came out, the majority in the 1990s. So let's compare that to cell phone technology, the type of, cell phones we had back then. You can imagine that brick phone, and then we progressed to a flip phone, and now we all walk around with, essentially mini computers. Being able to download third-party apps, third-party development, and similarly, that's the way I look at it with MSTP versus IP. Just really open to future development. So why would you want to kind of pigeonhole yourself with 1990s technology when you can have modern technology? And like all technology, things come down dramatically, in price. So if you're an early adopter of any new technology, it might be expensive, but now IP technology has been out in the building automation world for over 5 years. So they're priced very comparably.
Yeah. Yep. Absolutely. So let's go back to this network diagram for the final time. This I said we were going to consistently refer back to this whenever we first started the controls basics session. So I want to really tie up any loose ends on how this whole communication and BAS system is operating. So starting in this bottom right corner, we have all of our input-output wiring from our control devices going back to that unit level controller. That unit level controller in this case is communicating over IP, backnet over IP, back to the rest of this BAS network. And as you can see, everything's all networked together in that way. So we have everything networked together over IP in one consistent system. And then if you do have other devices that are MSTP, you can still most definitely have a system that is not, it doesn't have to be all IP or all MSTP. You can have a kind of mixed architecture, so to speak. And so as you can see, we're picking up some VFDs with backnet over MSTP here. As VFDs are starting to adopt backnet over IP, but I don't think that all manufacturers have gotten that consistently across the board yet. So it's good to know that you can put these technologies together in that way. Another thing to think about is that you can combine together multiple systems, whether it's multiple buildings, a whole campus, however you need to. And that's pretty much what this diagram is really going to show, is that with a BAS system, there are definitely ways to aggregate data, not only just for a single building, but multiple buildings, however you need to really make that work as an owner intends. So now we're going to move into wiring strategies, which I think this is a good, important discussion. And we'll start with the daisy chain over on the left. So the daisy chain is technically the same style wiring strategy that is used for MSTP, LAN, Modbus RTU. They use those serial communications. They used a daisy chain. And what's really good about a daisy chain is it cuts back on the amount of wiring that you're using. Your wiring costs go down, as opposed to something like this star home run, which is everything being wired back to a central point. A daisy chain, as you can definitely see here, a lot less wiring there. So that can help with your costs. That is a kind of false rumor that I've heard in the BAS industry a few times, that IP can't be daisy chained. And so I want to point that out right here. IP communication can most definitely be daisy chained. I'm not sure if every controls manufacturer has that functionality, but they definitely should, and it is available on the market. The next communication setup that we have here is a ring. So a ring strategy is pretty interesting. It allows communications to go both ways from this central switch. And mainly where you see this wiring strategy used is in data centers. It adds extra redundancy. to your setup. So if I were to come and cut this cable right here, we could still have communication go out this direction for these 3 controllers and then come out this direction for these 3. So physical break is able to be dealt with, so to speak, with this added redundancy with a ring. But there is a little bit more setup associated with that. So I mainly say to stick towards this if it's called for in a data center, but more often than not, a daisy chain strategy is going to be more than sufficient for any of your BAS designs. Then finally, if you are looking for, if you have some major piece of equipment that you really want to just be on their own link, and you don't want to have them daisy chained with anything else, you do have that ability with Ethernet to home run that back to your central point, your Ethernet switch. So a lot more strategies available with your BACnet over IP communication. As you can see, you have both ring and home run wiring strategies available with that BACnet over IP, whereas with BACnet MSTP, the only real wiring strategy you have is the daisy chain.
Mm-hmm. Yeah, and I guess quick add there, for many manufacturers, including Distech, do have some availability of a power over Ethernet controller. Specifically for us, we make a PoE VAV, and for that, the only supported architecture is the star. So just a single port per controller. But yeah, I'd say as if you guys are consulting engineers and you need assistance, to verify, always reach out to your respective Distech RSM, regional sales manager, that is.
Yeah. Yep. So PoE, that's a great point. You do need to be able to get that power to each individual controller, and the only way you can really do that is leveraging this star home run strategy. But it is a really good strategy if you have something like an old pneumatic system and you don't want to bring in a Division 26 electrical contractor and a BAS contractor, one running power, the other running communication for every VAV box. You do have the ability, if you're just going to do a pneumatic retrofit, something like that, to do these PoE switches with power over Ethernet controllers. So pretty cool, interesting use case there.
And quick tip would just make sure that switch supports PoE. That's my last plug for that slide. Guide to your homework and make sure the switch supports PoE.
Yep, absolutely. So this slide is showing us a few separate daisy chain links coming from a central switch. But one thing that I want to point out here is that something that you should be on the lookout for with your controllers is ones that have the ability to continue communication onto the next controller if there is a loss of power event. So if this controller was to lose power, you can still have communication continue on to these other smiley face controllers I have over here. So that's definitely a nice added functionality to have. It's just really a relay that snaps that communication together so it can continue on. And another thing to think about with your daisy chain strategy, always keep in mind, we like to say, I labeled it as the rule of 50. So IP communication, Cat6, Cat5 cabling, your Ethernet, your maximum distance is 100 meters. So you really don't want to have more than 50 meters between any individual controller. And the reason being is, say you had a situation such as this and you lost power here, as long as this whole link doesn't exceed 100 meters, you're still good with that communication. It's not exceeding your Ethernet maximum length there. And also, the rule of 50 comes into play that usually you don't want to have more than 50 controllers. That's probably a pretty consistent hard cutoff with a lot of manufacturers. is 50 controllers on a daisy chain IP link. So the shorter you keep these little daisy chain links, that is usually the preferred strategy. You're not going to be concerned about the amount of data throughput along that entire communication chain. Now here we're going to move into fiber as a conversation point. I think fiber is important to know about. It does become something that you're going to need in a few situations where you can't use your Cat5 Ethernet cable. So Cat5, it communicates at about, we said 100 megabits per second versus your fiber is at 1 terabit per second. And fiber also allows for a lot longer distances for communication. So the two scenarios that you need to have fiber in your building is, one, if you're exceeding the distance of that 100 meters with this Ethernet Cat5, Cat6, then you're going to need to use a fiber. So probably put fiber in between your switches and get a switch more localized so that you're not exceeding 100 meters between devices. Then the other scenario is if you have multiple kind of technologies being used, all using that same backbone, backbone of switches within your building. Things like security cameras and other technologies, they can have a lot of data that they're pushing through the system, and you don't want to bog down that system. So utilizing a fiber backbone, as we call it, allows you to expand out your system to implement more technologies like your lighting system, your security cameras, all that. So I would say if you're having more than one system combined into that network, you're going to want to use fiber for the backbone. And what that looks like is we're showing here. It's a fiber backbone with this yellow cable. And then we have Ethernet switches. In this case, we're showing them on every floor, which is a good practice to go out to your different controllers and devices on each floor. And two other things that I would label as preferences to see for fiber communication towards a backbone for a building would be whenever you're exceeding 250 controllers, I think that helps to have a fiber backbone. It allows you for more future expandability and good data throughput the whole way through the backbone of your building. Then also, if you're exceeding 5 floors, 5 switches, usually that's another good practice to have fiber as the backbone. So here's the final little discussion. Sorry, I did talk a lot on this one. I get excited about MSTP versus IP. But we do have just a quick comparison, customer network versus separate network. A lot of the information is right here on the slides, but the main thing that I'll just point out is that more often than not, a BAS, from the BAS side of things, we'd prefer to see a separate network used. Unless there's very good upfront coordination with the IT team, and the building IT team is very comfortable and familiar with building automation system devices, those are the times where you could combine together and leverage the customer's network. But a separate network is probably the right strategy if you don't have the means to have that upfront coordination. Anything to add to that, Steph?
No, that was great explanation.
Cool. So I guess with that, I wanted to say thank you to everybody that has joined us here this morning. It's definitely come back for the next few sessions. They're all really good stuff. I'm excited for this Thursday's session where we're going to talk about specifications, some of the problems that we run into, and how we can work together to alleviate those. But for those that have the time to stick around, we're going to go ahead and start running through the questions and try to answer as many of those as we can.
Awesome. Yep. Thank you, guys. So let's segue into some questions. Here is a question. What's the difference between a switch and a router? And I think I can handle this one. A switch usually refers to all local area networks, whereas a router can connect two separate local area networks or connect a local area network to the internet. So internet referring to a wide area network, a WAN versus the LAN.
Yep. Yeah. So the router kind of is allowing it more forms of more directions of communication.
All right. Grant, here's a really great question. Can you combine various wiring strategies on the same install?
Yeah, absolutely. Absolutely. So a lot of times what I'll see is sometimes major systems like maybe let's say like a chiller. You have a chiller that you just really want to make sure that that chiller is on its own little wiring chain. You could do a home run wire to that chiller, and then all of your fan coils or anything else you have in the building, you could leverage just something like the daisy chain wiring strategy. So you can definitely combine together those wiring strategies as you need to make sure that you're encompassing the system the way you want it.
Mm-hmm. And even one strategy we didn't go into great detail about, but it was on one of the architecture slides, is you can even add a Wi-Fi transmitter to your controller or two controllers rather, to make a Wi-Fi bridge. So that would be a great solution for maybe an atrium or somewhere where there's a high ceiling, or just you can't run a wire. So you can actually kind of connect two wired daisy chain networks. So that's another way to integrate a different strategy into your network.
Yep, definitely.
Okay, so here's a really great question. A separate network can refer to a subnet on the customer's network, or it can refer to an entirely separate intranet. Can you discuss the distinction?
Yeah, so a subnet is a way of kind of segregating your network, and it's a really good strategy in terms of your security for your system. You do want to be able to leverage not only subnets, but virtual LANs, and that way you're kind of segregating different systems. And so, yes, you can utilize a subnet within the customer's network as a means of segregating systems. That is a strategy I've seen used quite a bit. I think still it is a very good discussion that you want to make sure that that is fully understood with not all how you're setting that up with the IT team on site, and then also making sure you have the right number of IP addresses available. Everything still kind of needs to be brought into the right consideration there.
All right. Are PoE VAV controllers able to provide enough power to drive peripheral devices such as hot water reheat actuators?
Yeah, so the way we have them set up, they are our PoE VAV box controllers are able to still drive other peripheral devices, and that that is definitely something that was thought of while we were designing around those PoE VAV controllers, and that's probably why you don't see PoE at other devices like a large air handler controller. We wouldn't be able to really do PoE just because the amount of peripheral devices that you could possibly have with that could exceed the power that you have available over that Ethernet.
All right, so many good questions. This is another great question. Can a Jace with a secondary IP port be used as a backnet IP connection to remote controllers instead of requesting additional IP addresses from the IT department?
So yeah, what you could look to do is utilize a Jace as that primary connection point to the customer's network, and then have everything for your BAS built off of it. That is a good practice to not have a bunch of connection points to the customer's network. So yeah, that's definitely something that can be done and is a good strategy.
Oops, I was muted there. One quick announcement, then we'll go to the question. I'm going to, on the chat, post a link. So if you want to share with any peers about how to sign up for the any other additional sessions, either the one later today or later this week, you can sign up on distech-controls.com/HVAC workshop. So Nick, that's your question there. Okay, here's another great question. Where did it go? Grant, for a large install where, let's say hospital, data center, et cetera, would you recommend a separate network or utilizing the customer's network?
If it's a new installation, I would definitely be leaning towards a separate network. That way you don't have to do that upfront coordination with the IT team. And you know that everything's going to be covered. You're going to have the number of IP addresses that you need, all that. If it's an existing site, you could utilize the existing network, but it's really comes down to having a very well thought out process for how that works with the IT team, and make sure that they're fully comfortable with your devices living on their network.
Yeah, I'd say us as building automation professionals, we're getting more proficient in speaking, IT. It's just the way it is. You can't get around it. You can't ignore it. But yeah, usually, IT, the owner's IT group will probably have strong opinions on which way they want to go. And, oftentimes they might say they want to control it. They want to be, so I would guess it depends. Like everything, it depends.
Yeah. Yeah, I would say where I'm locally at, the most IT teams are pretty against having BAS controllers on their system. They don't know really what those controllers are doing, so they don't want to have to deal with them being on their network. But it has become something that IT professionals are getting more and more used to, seeing BAS controllers. And I think as that continues to expand, who knows, maybe we'll see a switch where it becomes the way to do it, everything being owned by the IT team. So we'll see, I would say, but more often than not, separate network from a BAS professional standpoint guarantees that you have what you need available for your entire system, and you're not getting caught up on coordination issues.
Another great question. How do you decide between using or among using several different communication topologies like daisy chain, ring, star?
More, I would say probably is, I don't want to make up statistics, but a vast majority of your installations, you're going to be using the daisy chain strategy. Purely, it's the least expensive form of install, and like I said, it is works perfectly fine for a BAS system. Definitely no issues with that daisy chain strategy. When you're going to be combining together other things is a lot of times comes down to preference or the application. Like I said, the ring is usually application is with data centers is where they like to see it. I don't see it used in office spaces or anything else all that often. And then home run, the usual preference is for very critical pieces of equipment is the preference that I typically see.
Let's see, I'm reviewing the questions here. How hard is fiber to assemble or to install?
So fiber is a little bit more difficult to install. You do need to make sure that your ends are clean before making connections. It is with that, there's an added cost towards installing fiber. The materials are a little bit more, but like I said, there are few circumstances where you absolutely need to use fiber. And there's a few where I kind of label as I would prefer to see it. So it's become more and more prevalent to see it as a backbone in large buildings. So there are professionals out there that are highly competent in installing it.
Awesome. And I'd say to learn more about some of these networking terms, things like that, Optigo Networks, they're a company that provides switches and routers specific for operational technology, building automation. So if you check out their website, they have a lot of really great videos and content for you guys to learn more. So I would say that's definitely a great resource. Grant, question here, video availability. We're going to be posting these or still to be determined?
Yeah, to my understanding, it's still to be determined what if we're going to have videos available for these. I know that definitely would be helpful for you guys to refer back to. For now, we do have the handouts available, and I think once there's kind of a consensus around a platform to put videos onto, we'll be sure to get back to you guys on that.
All right, here's maybe one last question here. In MSTP communication, if the wire is cut, you'll lose communication to the rest of the controllers, correct?
Yeah. So physical breaks in your setup, you're losing communication downstream. There's just nothing you can really do about that. It's kind of like your Christmas tree lights. You pull out one, and all the rest of them go out the whole way through. But that's where you see people wanting to try to use different wiring strategies besides the daisy chain. Is, that's why I said maybe critical pieces of equipment you want to have home run wired, or in data centers they utilize the added redundancy of the ring topology. But the good thing is that that IP wire is pretty robust whenever you're looking at an IP system, and it's less likely to be susceptible to issues like grounding. MSTP, it may not need to even be a physical cut in that wire in between controllers. Sometimes it's just purely bad grounding, lighting ballasts, other things that can cause that equivalent of a physical cut for your communication to get through.
Awesome. So I think that concludes our question answering period. Reminder, you can get the PDF handouts on the handouts tab. And then lastly, if you guys want to learn more and want to schedule a follow-up webinar with your respective Distech rep, you can go to our website, distech-controls.com. There will be resources at the top. Look for consulting engineer. You click there, and there is a place that's a scheduled lunch and learn, and then your request will be routed to your respective Distech rep. So again, if you're lucky, it might be me, might be Grant, or might be one of our other awesome peers, and we're all equally as passionate about building automation and helping differentiate MSTP versus IP and helping you design your system. All right, without further ado, I think that's a wrap, folks. If you can't get enough of us, please feel free to join us in a couple hours here at 11 a.m. Pacific or 2 p.m. Eastern. And thank you so much for the questions. And we'll see you guys next time on Thursday, which is Control Specifications Made Easy. We are going to review some of the top 10 spec mistakes and how to correct those, and a lot of other really great stuff. So without further ado, see you guys later. Thank you.
Thanks, everybody. See ya.
Bye.